This is an example of two bullwhips I've been working with. This one I bought from somewhere. It's been so long ago I don't remember where, but it was manufactured by somebody. And I did modify the handle, and I modified this part here, is what they call the cracker. But what I want to point out is, see this leather taper. It's thick here, and it gradually tapers down in diameter all the way down till you get down to the very end. I'm not sure what they call this, the fall or something like that, but that's called the cracker. This bullwhip here is one that I made myself based on a video that Adam Winrich, a champion bullwhip cracker, has on a YouTube video. Very easy to do. You just follow his directions, and simple, inexpensive materials save you some money, and it actually works great. I did modify this cracker here though, from his original design, but see the large diameter tapers down, and inside of this he describes how you put ball chain in there in such a way that the mass tapers as you come down to the end of it. So it's one to show you here, and that's what this whole bullwhip idea is based on, tapering mass. And one of the ideas is that due to conservation of momentum, as the whip is cracking, a wave travels down it, and since the mass decreases, the velocity increases. The bullwhip I made using Adam Winrich's design. Just go to his YouTube channel. It's called How to Make a Bullwhip. Easy to make. As you can see, it's got a tapered mass all the way down to this fall, and this cracker on the end. We'll give this one a try. I like to start out by just commenting on safety. Before you do anything with a bullwhip, these things are dangerous. They can hurt yourself. That's why I wear his hat and safety glasses. They can hurt anybody or anything, any pets, kids. You want to get them completely away from you because they can get seriously cut or hurt. What causes the whip crack? Well, if the tip of the bullwhip exceeds 770 miles per hour, the speed of sound, at sea level, and it's around 70 degrees F, you will hear a mini sonic boom or whip crack. What this video is all about is how the conservation of momentum of a wave traveling down decreasing mass in the whip contributes to the high velocity at the end, so it can break the speed of sound and cause the mini sonic boom or whip crack. Momentum is defined as the product of the mass times velocity. Conservation of momentum, that's also generally defined as the linear momentum in a closed system remains constant when no external forces are involved. This is best demonstrated with a Newton's cradle, which we'll show in just a minute here. This little device of suspended steel spheres is generally known as a Newton's cradle. They're all the same size and mass. We're going to give it a little try here, a little push. It's great for showing the conservation of momentum. As you can see, the velocity and movement is transferred through the center spheres to the one on the other end. If we push two of them at a time, it does a similar effect. Now what we're going to do is we're going to make a modified Newton's cradle that has a tapered size of spheres. We'll give that a try. This is an example of the bead necklace I used. It tapers very nice in very small beads all the way up to very large beads. Happens to be made in China. That's why I called it Chinese beads. But anyway, it worked very well for this. So that's what that looks like. This is our modified Newton's cradle. We're using the beads from the bead necklace I showed you. You can see how nicely they're tapered in size from this large bead here down to the small one. They're fairly elastic, not quite as good as a steel. And it'd be nice if they were more mass to them like the steel, but I think it'll still show. Now I'm going to give this bead here a little shove out, and you'll watch this bead on the very end here, how it really pops out. Now they get out of position a little bit, but it still shows that when you got mass times velocity, a certain velocity here, you end up with much higher velocity and a little further distance here. Now let's do the opposite. Let's take this one little one, go like that. It has almost no effect. We should see basically the same thing in a bullwhip made out of beads. With a tapered, from the handle being large down to the small, you should get a pretty good velocity. It should crack. If we go in the other direction, it should not. So we'll give that a try and see. So it really, I think this shows it pretty well. We're going to try a little slow motion video of this transfer of momentum from one side to the other. These are the beads that I used. They're made in China. They could have been made anywhere, but they're very convenient for this. I got a ruler here so you can see the approximate size of them and see how they're got a nice taper and mass, and that's why they're very convenient to use for this experiment. It's about a 12-inch long handle made out of 1/2-inch PVC with a couple of 1/2-inch PVC end caps, holes drilled in them, paracord run through them, and then wrapped up with black electrical tape. The paracord is laced through basically just plastic beads from 4 Chinese bead necklaces I bought off the internet. I had holes drilled in them. I had to widen the holes for some of the paracord, but tied an individual knot between each one. I just put that a marking pin down there for perspective. But you can see they get smaller and smaller and smaller. It's not a uniform taper. I just worked with whatever I had available in those necklaces. And the overall length of this is about just under 125 inches. The cracker is just the 1.85 millimeter paracord that I ended up with. I just tied a knot in the end to keep it from fraying too far up. And we'll show you how it works compared to other bullwhips here in a little bit. This is a homemade one I made based on Adam Winrich's design. He's got video, shows you how to do it. It works really well. Pretty easy to get it to crack. This is this modified, I call Chinese bead bullwhip with a tapered size of the beads on there to see if that transfer of momentum to a smaller and smaller mass size really make any difference. And it seems to, although you definitely need to wear some protective clothes with this. But it really, it is easier to get it to crack. Especially for somebody like me who really doesn't know what I'm doing. So I think it kind of proves the point when you've got this much mass starting out here and you put a wave into it. As it propagates down through here where it's smaller and smaller amount of mass, it does seem to make the end go faster and crack easier. At least that's my interpretation. Now, the tapered mass idea, I made something similar, just 5/32 paracord, no tapered mass at all, but the same kind of cracker on the end. Let's see what we can do with it. It's virtually useless. I made another one where I used some beads, wooden beads from the craft store. They're all the same size. They got the same kind of cracker on the end. By the way, a good reason for wearing a hat and safety glasses like I'm doing is you can mess yourself up with these things. Make sure no people, pets, kids, or anything are anywhere near you when you do this sort of thing. This thing is practically impossible to make it work like a bullwhip. kill myself trying to do this. That's it without. You can see in the video, it is possible to make this crack. Not as easy to use as the homemade Adam Winrich design. Works better than the lightweight, no taper at all, and the consistent bead size, same bead size, no taper, but neither one of those worked at all. But you can make this crack. What we're going to do is reverse the taper, put the handle on the opposite end, reverse the ends with the cracker and the handle, and we'll see if we can make that crack. You can see it works pretty good. Now what we're going to do is reverse the taper and see if we can make it work with reverse taper. That'll show us how important that tapered mass is. I've reversed the taper in this bead bullwhip. I've connected the handle to the small end. Some of the beads have gotten broken off due to the cracking that I've done with it, but tapers up actually to the large bead end where I put the cracker. I don't think I'm going to be able to do much with this. We'll see. Well, I'm no champion bullwhip cracker, but I can crack it with the normal taper. I can't even get a wave to propagate through it with the reverse taper. So it's obviously pretty important tapered mass. Just for fun, we're going to do a couple of slow motions on these things. I highly recommend that if you're just learning about how to crack a bullwhip, there's a lot of good videos out there on the internet, good whip cracking demonstrations. This is the science geek version of it, which is not that great. I was more interested in the physics of the tapered mass than I was trying to make a really good whip crack. Anyway, don't waste your money if you're just beginning on a leather bullwhip. I would go to Adam Winrich's YouTube channel and follow his instruction. Real easy to do, and it works better as far as I'm concerned.